Okay. 4.7 section, combining rational trig expressions. Why does it say rational? It's simply saying we're going to have some trig expressions written in the form of fractions. Nothing but fractions. So expect that we're going to recall on basic fraction operations a lot, because that's mainly the skills that we are applying onto this fractional form of trig expression, okay? As we've been doing from couple of the sections before, and today I technically picked these 5 examples directly from the practice problem. So you guys can just do based on this reference. Okay, first one, what do you notice? The numerator is written its simplest form already, but there's familiar expression that we've been using over and over again. It's 1 minus cosine squared of x. What trig identities do you expect to use here? The basics of basics, the trig identity of the Pythagorean trig identities here, right? So as we can easily connect the denominator 1 minus cosine square of x equivalent to sine square, then we can simply rewrite it. Thanks to this, I can simply rewrite this part is in the next step. It's sine square of x already. And I copy numerator as it is, sine square of x. Oh, then this becomes very simple. Same factors from top and bottom, and then it's gonna make just 1. And you should be able to recognize the answer choice of this problem in the practice problem section 4.7 as number 1 there, value 1. Okay, easy peasy. Okay, so that was just kind of warming up. Then move on. Oh, any question? Okay. Now number 2, we have cosine on the numerator, and we have secant of x minus tangent of x. And what should we do first? Since I have the mixture of the language, and there's a cosine, and there's a secant, and then there's tangent, probably instinctively it hits us with rewriting some of trig functions into the unified language. Then I can rewrite secant in language of cosine. I can rewrite tangent in language of cosine and sine. So that might be our first step. Yeah. Okay, so let's rewrite it. Now, cosine on numerator is just cosine still. Then now secant, yeah, I can rewrite it 1 over cosine x, and minus, instead of tangent, I can rewrite it sine x over cosine x here. Then let's take a look at the structure here. First structure that I notice, the whole fraction is the complex fraction. And then I will have fractions in the top and bottom. And also, the numerator side, I have separate 2 fractions. One is 1 over cosine x minus sine over cosine of x there, then probably I can utilize the fractional adding, subtracting skills and complex fraction strategies so that I can rewrite given expressions. So this is the key for us to do, right? Then now, remember how we add fractions here. Then, especially the denominator. Two fractions separately, 1 over cosine x and sine over cosine x, they are fractions that already have common denominators there, right? So it's easy for us to just combine the fractions on the denominator in the next step. So now these two fractions will be added together. Now the common denominator between two fractions is cosine of x. Then once you have the common denominator, and you can just go ahead and operate the numerator. So it's going to be negative 1 minus sine x. Then also I will copy cosine x on the top. Now I have cosine x on the top, and denominator is one fraction there. Then we can utilize the complex fraction here in the next step. Then the numerator cosine x can be written in the fractional form cosine x over 1. Then now I have to reciprocal the bottom fraction, so it's going to be cosine x on top. Now it's 1 minus sine x on the bottom. Then when you multiply fraction and you crossly multiply numerator, numerator, denominator, denominator, the next step will be cosine square x. You multiply cosine x and cosine x. And then 1 times 1 minus sine x is 1 minus sine x. Then again, I notice cosine square of x will be from here 1 minus sine square of x, right? So I can rewrite cosine square of x into 1 minus sine square of x, and the denominator will be still 1 minus sine x. Then another tip. Again and again and again, it's difference of squares. Then the numerator 1 minus sine square x can be factored into this form. 1 minus sine of x times 1 plus sine of x. Then let's say denominator is still 1 minus sine of x here. Then what do you notice? I do have same factor top and bottom so that I can cancel this and this. Then what's left is 1 plus sine x, and that's the final answer here. Okay, well, a lot of skills that we saw all together at once. So keys are, you should know how to properly add and subtract fractions, and it's going to be applied the same way. Then, of course, you saw one of the Pythagorean trig identities to rewrite, and it benefits us to unify the language, and then it's easier to simplify. Then also a lot of times that you get to see 1 minus sine square or 1 minus cosine square, and it also connects to the difference of squares format, then you can factor and you can cancel and further simplification happens. So I need you guys to see overall connections and each connections from given expression to all the equipped trig identities that you can utilize. Okay, any question so far? No? Okay, then number 3. Number 3 is actually very, very important too. So let me save this. Clear. Here we go. It's number 3. Okay, now I need you guys to see the part of numerator can utilize the basics of Pythagorean trig identities there already. So let's have it out here. Cosine square of theta is 1 minus sine square of theta, and I can rewrite it there, right? So then cotangent x, and then I will rewrite the part with plus cosine square of x, and then I can copy the denominator cosine of x there, right? Then now I can rewrite cotangent into the language of cosine and sine. So here, notice I can rewrite cotangent is cosine on top, sine on the bottom. Then the rest of them will be just the same. Then now, I have cosine of x over sine of x plus cosine square of x all over cosine x. Then I suggest you guys to see some cool fractional trick here. As we saw in previous problem, if you have a over c plus b over c, and you're supposed to go ahead add the numerator because the c, which is the common denominator, was already given. Then if you look at that procedure in backwards, if you have two numerator added over one denominator, you can separate them into two fractions that has exactly the same denominator as well. So then let's see this given step 3 as you separate this fraction and this fraction in the next step. Then it's gonna look like this. First, cosine x over sine x all over cosine x, and it's added. Then the blue part will be cosine square of x over cosine x. Then we can simplify each fraction separately. The first red fraction will utilize the complex fraction skills. Then it's going to be cosine x over sine x times, this is over 1 here, and then it's going to be now 1 over cosine x. And then the second fraction is cosine square of x over cosine. So this will cancel the square, and then it's just cosine x by itself. Then notice from the first fraction, I can cancel cosine from top and bottom. Then next step will get us 1 over sine x plus cosine x. Then by this step, and you can check your answer choices given, and one of them that is equivalent is cosecant x plus cosine x, which is simply we rewrite 1 over sine into the reciprocal, which is cosecant, and that's it. So this should be included the group of the answer choices there. And let's see. The key of this type of problem that we should be able to utilize the rewriting the fractions separately or combining as the situation requires, right? Earlier, we were adding to have less number of separate fractions, but in this case, actually going backwards was really beneficial. So you should be able to recognize how we can deal with the fractions, because those skills can apply directly to this type of rewriting trig expressions. Any questions? Okay, I hope you guys are processing as we move. Okay, then let's do number 4 here. Number 4. Okay, now I have cosecant of x plus 1 over cotangent of x plus cosine. And first step for us to do is rewrite everything into the same language. Cosecant will be 1 over sine of x, and then 1 is 1. And cotangent can be cosine over sine, and we can go from there. So let's rewrite the recognized part here. So I will rewrite this, I will rewrite this. Then it's gonna be cosecant being 1 over sine x, and it's copied from 1, and all over, instead of cotangent, I can write cosine x over sine x, then it's plus cosine x. Then now I need you guys to remember some fraction operations here. If you are given with 1 over a plus 1, then the integer 1 can be manipulated by multiplying fraction that has the same factor from numerator and denominator. Then especially in this case, if you make that integer 1 into a fraction that does have common denominator with the other fraction already given, then it's gonna benefit you to have combined fractions, right? Here, this is a really important key. Then this is skills that makes possible for us to combine the fractional expressions there. So if you understood that, then the step that we have right now, I can multiply here 1, it's gonna be sine x over sine x. Then also, this cosine on the bottom it's over 1. Then also I can multiply sine x over sine x. So this is sine x, this is sine x, and this is sine x, this is sine x, and then they're all sine x. Then I can go ahead, combine them. Then next step, the numerator will be 1 plus sine x over common denominator sine x all over cosine x plus cosine x times sine x all over sine x on the bottom. Then now we have fraction on top, fraction on the bottom. Again, complex fraction skills here. The next step, I can rewrite 1 plus sine x over sine x from the top. Then I have to flip the denominator fraction. So it's going to be sine x. Then notice the new denominator has cosine and cosine from both terms. Then we can factor the common factor out, and then it's going to be cosine x out in 1 plus sine x. I just factor cosine x and cosine x from that numerator there. But now it's denominator because we are rewriting complex fraction, right? Then let's see. I can cancel sine x and sine x. I can also cancel 1 plus sine x, 1 plus sine x. And only survivor from this cancellation into the next step is 1 over cosine of x, which can be rewritten as secant x, reciprocal of secant x. So I need you guys to realize this trick up here is very, very important. And I try to color code step by step what we are rewriting so you guys can see the steps as it changes later, okay? And just try to follow the steps that I just move on, like as I move on. Any questions? We have only one problem left. Okay, if not, then we'll save it and clear. And the last one. Okay, the numerator is obviously making us utilize the cofunction identities. Tangent of 90 degree minus x is cotangent of the angle x. Then we can go from there. Then also, the denominator has a sign of the negative x there, and this one indicates the even and odd trig identities. If you guys don't remember, please go back to last week instruction, and it was like a couple of the last slides there, okay? So then, based on this, and then we can rewrite everything that we can do. So, the numerator tangent of pi over 2 minus x can be cotangent of x based on that cofunction identities. And I will rewrite cosecant right away, 1 over sine x. Then I can recognize sine function being odd function. So if you have negative input, it's gonna change the whole function sign. So now it's not plus, it's minus sine of just positive x there. Then still, I need to rewrite cotangent on top. So it's gonna get me cosine x over sine x over 1 minus sine x minus sine of x right here, right? Then again, now I recognize combining will happen. So this is over 1. And in order to make the denominator same as the sine of x, and then I have to multiply sine x top and bottom, right? Then let's see what happens. So I will copy the top fraction as is. Then it's 1 over sine x minus sine square x over sine x. Then now cosine x sine x times, let's flip this. Then in this case, this one can be combined as a one fraction. It's 1 minus sine square x, right? So then that's gonna be on the bottom this time, 1 minus sine square x. And then the denominator of the denominator will be numerator of the second fraction now. It's just sine x here. Then recognize something here. Then now again, there's Pythagorean trig identity here. Then it's going to be cosine x, sine x, sine x, cosine square of x. Then canceling cosine x with one of the cosine x, sine x and sine x will get you 1 over cosine x. And again, it's secant x. That's all. Okay, any question? That was